Okay, guys, so this is going to be the second half of 4.1. Okay, so we're starting at, let's see, I think this is on page 62. Okay, so moving on to the part where we're discovering the mean value theorem. Okay, so the idea of this is we're taking these functions and we're going to start by drawing the secant lines between the A point and the B point. And then there should exist a line that is parallel to that line along the function somewhere in between. Okay, so if I draw a line between A and B, so this is considered our secant line. So a secant line is just some line that joins 2 points. Okay, so the tangent line that's parallel is going to be the one that's the same slope that kind of only touches at one spot. Okay, so that would be right there, that second line would be our parallel tangent line. Okay, if we looked at question number 11, okay, again connecting the A and the B. Okay, so where would the tangent line exist? Okay, so for this one, there could be one right here. And there could also be one on this other side. So this one could have two possible places where the tangent slope is equal to the secant slope. Okay, so on question number 12, again, we can connect these 2 points. Okay, and on this one, the slope from here to here keeps going up, and then from here to here it's down. You cannot create a tangent line on a point because that is a non-differentiable point, okay, because it's a sharp point. So this one would have no tangent line for that particular case, okay, because the one spot where it could possibly exist is a sharp point. If we go to 13, okay, again, we can connect these 2 points. Okay, so on this one, there's really no place. This one just becomes steeper and steeper and becomes vertical almost. And same with over here. So since the function also is not continuous between A and B, there can be no tangent line. Okay. For question number 14. Okay, so for point A, there's this vertical asymptote where the function is not ever getting to, and then we got our point B. So for this one, there is no secant line. So if there's no secant line, there can be no tangent line. Okay, so notice these different cases where the tangent lines are not existing. Okay, so if we look at 15, again, we got A to B, so that's secant line. Okay, and then our potential tangent line would be up here, but you notice that there's a hole. Okay, so can you create a tangent line at a hole? No, you can't. Okay, so it is a point of discontinuity. So no tangent line on that scenario either. Okay, so moving down a little bit further. Oops, those are our answers for those. Okay, so for this one, we'll just go a little bit further. So at this point, they ask us to first draw the secant line between the x value of 2 and the y value, or excuse me, the x value of 2 and the x value of 5. Okay, so if we look at question 16, there's my secant. Okay, so since the function is continuous, it has a tangent line, and we can say that the parallel line to that would be somewhere right in that area. Okay, so if that's the tangent line, at what x value is that tangent line existing at? So I would say right on that spot, kind of. So I would say the c value would be close to the value of 3. Okay, so if we try that again on question number 17. Okay, we have our secant line in blue. Okay, so the two slopes on this one that are kind of tangent to that would be, I would say, right there. And somewhere in there. Okay, so that would be my x value. So I would estimate that to be, I don't know, 2 points, a little bit, maybe further than 2.5, so like 2.7 maybe. 2.7. And then this one kind of looks like maybe 4.7. Okay. So then if we look at question number 18, we draw our secant line. So this one has, there's kind of 3 spots it looks like that they can have a tangent line. So there's this one up here, right there. This one down here, and then this one up here again. Okay, so this one has 3 possibles. So I'd say that one looks like about 2.5. This one, maybe about 3.5. And this one, let's call that 4.5. Okay. So what does this all mean? Okay, so here's the mean value theorem. If f is continuous, notice that part right there, between the two x values, column A and B, and it's differentiable, okay, which means there isn't a sharp turn or a vertical tangent line. Remember, those are 2 also places that you cannot derive at. Then there's going to exist some c value in between a and b such that the derivative of our function is equal to, hopefully you recognize this formula. Okay, so this formula right here is really the same as your y2 minus y1 over x2 minus x1. Okay, what is this formula that we've been using in the past? This is used for the average rate of change. Okay, so this mean volume theorem is saying that the instantaneous rate of change is going to be equal to the average rate of change as long as our function is continuous between our 2 x values and differentiable between the 2 x values. Okay, that our average rate of change will somewhere equal our instantaneous rate of change. Okay, so that's this whole sentence right here that will equal each other. Okay, so that's a pretty crazy idea, but makes complete sense. Okay, so let's go ahead and do this. So let's start with finding our average rate of change. So given our function, we are giving this interval between 3 and 6. Remember, these are 2 x values. Okay, so to find my corresponding y values, the first thing that I have to do is I have to plug those values in. So if I plug 6 in, I have 3 minus 6 over 6, which is 3 minus 1, so a corresponding y value of 2. So we're looking at 6, 2 for 1 point. If I plug 3 in, I have 3 minus 6 over 3, so 3 minus 2, so we get 1 for the y value of that one, so 3, 1. Okay, so if I do average rate of change, we're going to do y2 minus y1 over x2 minus x1. So if we simplify that, let's see, we get 2 minus 1 is 1, 6 minus 3 is 3, so we get 1/3. Okay, and then if we go on the other side of that and do our instantaneous rate of change. Okay, so instantaneous rate of change, let's say, is simply our derivative, right? Okay, so the derivative of our f of x would be, let's see, I'm going to go one step back really quick because we have a fraction involved. That would be the same as 3 minus, if I have my x in the denominator, if I pull that up, it would be x to the negative 1. Okay, so now I can derive these 2 terms. The derivative of 3 is 0, so I don't have to say 0. And then the derivative of this piece, I have negative 6 times negative 1, which would be a positive 6, and then x to the negative 2. So if I rewrite that, that would be the same as 6 over x squared. Okay, so by the mean value theorem, I'm going to take my average rate of change, set it equal to the instantaneous rate of change to find my x value, which they're going to call the c. Okay, so 1/3 is equal to 6 over x squared. And I'm just going to solve this. So I would solve this by cross multiplying. So I have x squared times 1, which is x squared. And that's going to equal 3 times 6, which is 18. So if I take the square root, so the square root of 18 would be 9 times 2. So the square root of 9 is 3. So we get 3 square roots of 2. Okay, so what you want to consider is the interval that we just found. Okay, this still has to exist between the two x values that we were thinking about, 3 and 6. So since we have a positive 3 squared root of 2 and a negative 3 squared root of 2, the negative cannot work for us because it's not within the interval. It's a value less than 0. So only the positive value is going to be the true C value. Okay, so I should actually say instead that of x, that our value is C, because that's what they're asking us to find. Okay, so I just want to go through the homework problems that I gave to you on Friday and make sure that you do have the right answers. So hopefully you can check this. Okay, so for 1, the absolute max would be at the x value of 3. Or excuse me, not x value, but the y value of 3. For 2, the global minimum is at the point, should have that in order paired there, is 5, negative 2. The relative minimum values are at 0, at x equals 0. And then at this hole, there's one at 4. And then that bottom of that B piece is at 5. For question number 4, the relative max, there's only one of those right here at that point, which is at x equals 1. Okay, I asked you to do 5 and 6. So for 5, you should get 3 halves. Okay, so you're just setting that equal to 0, the derivative equal to 0. That one's pretty straightforward. For question number 6, you take the derivative, which you get 4x to the negative 1/3 minus 2. Take the x, put it into the denominator, and hopefully at that point in time you realize anytime there's an x in the denominator, that creates a critical value. So that's why we have a 0 there. And then the second one comes from setting it equal to 0. So I would add 2, multiply by the x, divide by 2, and then cube both sides to get the 8. Okay, so I'm going to keep going here. Hopefully you have this out. So you're going to continue your assignment. Your assignment is going to be to complete the rest of this assignment by the next time I see you. I'm just going to kind of go through a couple of these with you though. If we go to question number 7, okay, if you set, or first find the derivative of this function, which happens to be a straight line, the derivative, or the slope, is always going to be negative 2. Okay, if you set 0 equal to negative 2, there's no x value for you to find for this question. So for this one, there is no critical value. And that kind of makes sense if you think about a straight line. This one will have a negative slope. Okay, there is no maximum or minimum. There's just, they just go to infinity in both directions. Okay, so question number 7 has no critical values. For question number 8, this one is one where you're going to have to think about the graph of this function. You have a absolute value with a plus 2. So plus 2 is going to move into the left direction. It's just a V. Okay, so we can say, oh, okay, there's the bottom of that V. That critical value is going to be at negative 2. Okay, I'm going to go ahead and do a couple more of these with you just to refresh on what we did on Friday. Okay, so question number 9 is asking us to, without using a calculator, find the absolute max, absolute min values. Okay, so hopefully you can remember. To start this, we take the derivative of our function. So if we have x squared minus 3x, the derivative of that is 2x minus 3. Okay, when I look at this, I have no x in the denominator, so I have nothing to worry about with a critical value from that. To find a max or a min, I'm going to plug 0 in, or set my function equal to 0 and solve that. So I can add 3, divide by 2, so I get a critical value at 3 halves. Okay, so since my interval is between negative 1 and 5, and x does exist in between those two values, to find my absolute max, absolute min, I'm going to plug all three values into my original function. So I'm going to start from the smallest, so f of -1. Let's see, my original was x squared minus 3 times x. So that's going to be 1 plus 3 to make 4. If I plug in 3 halves, we get 3 halves squared minus 3 times 3 halves. 3 halves squared would be 9/4 minus, this is going to be 9 halves. I'm going to put in terms of fourths. So 9 times 2 is 18/4. So 9 minus 18 is -9/4 for that one. Add 5. We have 5 squared minus 3 times 5. So that would be 25 minus 15 for a value of 10. So I get a max f value of 10, and I get a min f value of -9/4. Okay. So maybe I'll do one more with you, and then do one more of these mean value theorem ones. Let's see which one looks like fun. I think I'm going to go to question 15. So if this is out of order for your assignment, just keep going. It'll be fine. So what I want to do for this particular function is I notice that we have, I'm just going to write it over here so it's easy to see, a fraction. Okay, so first step is to find any places where my original function is not continuous. So is there any value that would make this denominator equal to 0? Okay, and in this particular case there is nothing, because if you square something and then add a positive value, you'll still have some positive number. So the function is continuous. So that's not a worry. We can go ahead and find its derivative. I'm going to change colors here. So how would we find the derivative of this particular piece? Hopefully you're saying, oh, I have to do the quotient rule. So we're going to go ho, make sure you use parentheses. D high, the derivative of x squared would be 2x minus the high, x squared, d ho, so the derivative of x squared plus 2 would be 2x all over the whole squared. Squared. Okay, so if I simplify that, I'm going to distribute the 2x on this piece. So I'm going to get 2x cubed plus 4x minus 2x cubed all over our bottom piece. And we end up canceling x cubes and getting 4x over x squared plus 2 squared. Okay, so that's your derivative. Okay, so at this point, again, I need to say, is there any value that's going to make this denominator undefined? And since it's basically the same as the original, there is no value. Okay, so do remember, any value at any point in time that makes the denominator 0 becomes a critical number that we would have to test for max and min. Since there isn't, we're going to just set our derivative equal to 0. This actually is far easier than this looks to be. Since it's set equal to 0, I would multiply this denominator to the other side, and since I have 0 times the whole piece right here, it just becomes 0 equals 4x, and I get a critical value at 0. So I go back to my interval piece, so I'm going to test my original function from the smallest x value of -1, since that's my lowest interval value. So -1 squared over -1 squared plus 2. By the way, can I cancel these two out right there? I hope you said no and you yelled it out loud, because you really can't, and there were people who did that on the test, so dang it. Alright, so we got 1 over 1 plus 2, which gives us 1/3 here. When we plug 0 in, I hope you can go straight to the solution for that one, because you get 0 over 0 plus 2, which is 0 over 2. which is 0. And if I plug in 2, I get 2 squared over 2 squared plus 2, so that makes 4 over 6, which is 2/3. So I have a max f value at 2/3 and a min f value at 0. Okay, so I'll let you play with the rest of those. They're not too bad. 13 is probably the most complicated. Make sure you kind of think back to question number 8 with that one. 14, make sure to distribute the 3 before you go ahead and distribute. And be careful on question number 10 because there's a critical value from a value that makes the denominator 0 on this. Okay, so moving down through the assignment, let's do maybe 1 or 2 of these. Okay, so for question number 16, it says to find the absolute minimum and maximum values of the function. Okay, so what would the absolute minimum be for that value? Okay, remember what kind of values are you using between 1 and 3? Notice that. Okay, hopefully you said, oh, we're using y values. So the absolute min is 0 at that bottom piece. The absolute max goes up as high as 3. Okay, let's do 17 while we're at this. So question 17 starts here at this point and continues upwards. This is representing a vertical asymptote there at 3. So absolute min, lowest y value, is definitely 0 because it exists at that point. Absolute max. Okay, does it go up to a single number? No, it goes up to infinity, and since we cannot say it exists at a finite value, we're going to say there is none. No maximum. Okay, so I'm going to let you finish those. Okay, let's do question 20 just to do some practice on the mean value theorem. So first of all, the question says, does the mean value theorem apply to the given function on that interval? And if it does, find a c value. Okay, do not use a calculator. Okay, so for question number 20, we have this absolute value of x. Okay, so they're throwing this at us a lot in this section. If you think about the absolute value of x, you should say, oh, it's a v. Okay, so if I think about this function, number 1, is it continuous? Yes, I drew that without lifting my pencil. Number 2, is it differentiable between -1 and 3? And at this point, I hope you're saying no, because there exists a sharp point right at 0. Okay, so since it's not differentiable between the interval, we cannot use the mean value theorem. So we have to say mean, actually let's just abbreviate that. Let's say maybe value theorem does apply. Okay, and I'm going to say sharp turn not differentiable at x equals 0, just for clarity on that. So that is why you can't use the mean value theorem on that question. All right, so let's try one where you actually can use it. Let's do question number 21. Okay. All right, so we have x squared minus 2x. So that is a continuous function. We know it's a parabola. There's no gaps. There's no discontinuity between our intervals. So we can go ahead and derive it. So the derivative between that in that is going to be 2x minus 2. Okay, so then I'm going to do on my interval, remember those are two x values. So I'm going to say f of 3 would be, let's see, 3 squared minus 2 times 3 would be 9 minus 6 to make 3. So that's a point at 3, 3. And at 1, we get, let's see, 1 squared minus 2 times 1 would be 1 minus 2 to get negative 1. So that point would be 1, negative 1. Okay, so the mean value theorem is y2 minus the y1 over the x2 minus the x1. That would be 4 over 2, which I'm going to say is the same as 2. And that tells us that that should equal the derivative, or the instantaneous rate of change. So if we solve that for x, let's see, I would add 2. That's 4 is equal to 2x divided by 2. And we get an x value, but I'm going to call it c because they want to use a c value for the intermediate value theorem. So we're going to say the c value happens to be 2. And 2 should exist between the interval 1 and 3, and in fact it does. Okay, so I'm going to let you play with the rest of those. Okay, so remember to be careful about things that are not continuous between your intervals. And then the rest of this you should be good on. Okay, so please finish this assignment for the next time I see you.